So, example 2. I told you to kind of graph that from mine, and then was asked, well, how would you graph that if you had to? And I said, well, that's a pretty good question. We'll have to take a look at that then. Basically, for you to graph it on a TI-83, it has to be y equals. This is not y equals, it's x equals. I'm not sure about the inspires. I think you might be able to do those x equals. You'd have to take a look. So basically, we have to get y all by itself. Well, that's a problem because y is in the exponent. Yeah, we got to get somehow cancel out the e. And what's the one thing that'll cancel out e? Natural log. So we take the natural log of both sides. And what happens on the right side then? Natural log and e cancel each other. So we basically get the natural log of x equals negative y squared. So probably divide by the negative 1 that's sitting out front. And take the square root. So y equals the square root of negative natural log of x. It would technically be positive and negative, but based on where we're supposed to be looking, And so basically this graph does continue up way up to here, but for you it's a y value of 0 to 1 on your notes. Okay, so a typo on mine. And so notice I went from 0 to 1 on a y value and I just stopped. I think the x value is like 0.24 or something like that is where this actually happens. So my graph's a little off, but it's very close. So that's how you would do that if you had to. Okay? Now I am going to ask you to revolve it around the x-axis. So which way should my rectangle go? Horizontal or vertical if we're using shell? Horizontal because you have to go parallel. Okay. So it will look something like that. So we're doing shell. So what goes out front? 2 pi. Because we're doing shell, yeah, and its circumference. From where to where? Well, it says for y goes 0 to 1. We know these are dy, yep, because it's going to the y-axis. There it is, dy. So once again, the hardest thing to figure out, radius and height. So the height of this one right here, isn't it the function? How about if I did the one that's down here? Would the height also be the function? Yep, so the function, yeah, how are you going to do that? Yeah, it's with respect to y, though, so it has to be solved for x like they are. So it actually is just e to the negative y squared. What's the radius? Remember how I do that? I just pick so let's say I put it right here at 1/2 is where I put the rectangle. Is 1/2 also the radius? Distance from there to the axis revolution, is it also a half? What if I went to 1/4 and I put it there instead? Is the radius 1/4? And let's just try one more, 3/4. If I went there, is that radius 3/4? Again, distance to the axis revolution. It is because I chose the x-axis. So in this case, the radius is just y. So it's 2 pi times the radius times the height times the width, which is dy. You could, but I would very much love to do this one by hand. Because it's been a while since we've had one where we had to take the antiderivative by this particular method.
Oh, by parts?
We don't quite need by parts. It is close. Because do we know how to take the antiderivative of e to the u? The antiderivative of e to the u is e to the u. So if I could get this to say e to the u, that'd be beautiful. So u is negative y squared, and the derivative of that happens to be kind of sitting here somewhere. So that works out fairly well. So let's go. What's this called again when you have just u and du? Substitution. So u is negative y squared. Du is negative 2y dy. Well, that's your choice at this point, because we kind of do have the 2. We kind of do have the 2. It's your choice whether you want to use it that way or not, because the 2's sitting out front. Yeah, exactly. You might save you time. It's what you want to do. But we do not have the negative. So we do have to divide by a negative. So you just want to divide by negative 2 and do it the way that you're used to? Okay. Divide by negative 2. You can do that, yes. It'll work out the same, you'll see. So let's start rewriting it. The 2 pi is still out there. Do you agree? So 2 pi is still there. We also have to now put the negative 1/2 du. So the negative 1/2 we normally put out front. Integral. Okay, so this is gone. So the y and the dy are getting replaced by negative 1/2 du. Is the e getting replaced? Is the negative y squared getting replaced with? So do you agree if you do it that way, that's how you end up? You see how the 2 pretty much takes care of itself anyways? Whether you do it the way I suggested or we do it the way you're more familiar with, it takes care of itself anyways. Or like somebody said, can't we just put the negative out front? And isn't that really what ended up happening? Okay, because the 2 and the 1/2 are gone, so it's really a negative pi sitting out front. Negative pi. Now, you may have noticed I didn't put any numbers in. That's because you have to decide, do you want to switch them to u's? Or do you want to just bring everything back to y's when we're done? So we have to convert them then? I don't have a problem. We're just substituting it in here. So put 0 in there. What do you got?
0.
All right, so the 0 stays a 0. You put 1 in and it becomes a negative 1. Right? So we got it from 0 to negative 1 of just e to the u. Whoop, du. I just cleaned it up a little bit. What is e to the u's antiderivative again?
E to the u.
Okay, so we basically have negative pi times e to the u, and u is, well, let's leave it as u, right, because you wanted to do it that way. From, so why didn't I put y back in? We chose not to, yeah, we chose to use the values of u. So we put the negative 1 in, and we basically have negative pi times e to the negative 1 minus whatever I get when I put in 0. E to the 0 is? Okay, so e to the 0 is 1 times negative pi is negative pi, correct? So you can leave the answer that way if you would like. Or factor a negative pi out if you want. And it's e to the negative 1 minus 1. Very good. That's probably how the book would write it right there, would be my guess. Probably. What'd you get? Oh. If you got a decimal of, say, I don't know, 1.986, then you did fine. Is that what you got when you did the x's from the beginning, Jake? Or did you do it here on your calculator? Or? Oh, okay. Now, the problem is, if you graphed this one, you probably did it with respect to x. Your calculators, I don't know how to make them go with respect to y. Okay, but what you have to do is you have to type it in this way, right here in red, just using x's. You can't type in that natural log graph. You have to type it in this way, and this is where that other place I showed you, math, and what's it, number 9? The fn comes in handy because you can just put x's in those places, and it'll do it for you. Okay? I think when you hit E, doesn't it automatically give you a parenthesis? So you put negative x squared?
I just keep it box and keep it.
Oh, okay. Yeah, so probably to be safe, yeah.